So on this slide, what you see is essentially kind of a taxonomic evolution of how we've thought of psychedelics. So originally they were called psychotomimetic, meaning that to an outside observer, it mimics psychosis. So it's not even what the person is experiencing, it's what a person that's looking at them thinks about what they're experiencing. And then you have terms like hallucinogen, which, I don't know, in some ways, that's one aspect of what psychedelics are capable of, but it really seems like a very kind of blinder view of the psychedelic experience. I like terms like psychedelic the best because it just means mind manifesting. It's more of an umbrella term that could potentially fit many of the substances. And then you have some more, I would say, like newer terms that are more specific to some of the subjective effects of different psychedelic compounds. So entheogen, meaning to generate the divine from within, I think of more of like a psilocybin experience or a mystical type of experience, whereas enactogen or empathogen, I think more of to touch within or to generate a state of empathy, seems more associated with the subjective effects of MDMA. But as far as this slide goes, the term that I really want to introduce you to is psychoplastogen, because this is the first time that we've had a word to describe the effects of psychedelics as far as how they're affecting our neurobiology, instead of an observer or sort of a subjective perspective of the effect of the drug. And it seems that psychedelics are able to promote neurogenesis, or essentially the growth of new neurons, or synaptogenesis, meaning the connections, the formation of new connections between existing neurons in key regions of the brain that have been linked to mood disorders, including areas of the prefrontal cortex, like the medial or dorsolateral prefrontal cortex, as well as areas of the limbic system. And these kind of areas of the prefrontal cortex and the limbic system, kind of deeper in the brain, are functionally linked together in a circuit called the default mode network. And it appears that many psychedelics can acutely diminish the effects of the default mode network, which is linked with a sense of self. So a diminishment of a sense of self and more of a sense of everything else, and the ability for disparate brain regions that aren't normally connected to talk to each other a little bit more. So it seems that the psychedelic is working on this functionally interconnected network of the brain to inherently, shut it down temporarily, allow some different types of neural communication to happen. And then as the psychedelic experience wears off, there's this potential for a reorganization of a person's kind of neural circuitry. So this kind of theory that I presented here on this slide is probably most out there with the serotonergic psychedelics like MDMA or psilocybin, but there actually is some overlap in the mechanism of ketamine with these serotonergic psychedelics, particularly kind of converging in areas of the prefrontal cortex. So I think this slide talks about neurobiology a lot and what the psychedelics are doing in the brain, but I'm also really kind of interested in the somatic effects of psychedelics and what they're kind of doing in the periphery. And along those lines, it really hasn't been a ton elucidating what psychedelic effects are in the periphery or what comes from those sort of peripheral effects. But things like ketamine, for example, are really, really known for other types of properties, anesthesia, analgesic, and sedative types of properties. And, you may be thinking of these things in tandem, what am I hoping to happen in the person's brain, but what am I hoping to happen in the periphery kind of at the same time? And that could sometimes maybe inform your choice of which substance.